Why, hello. It's been a while. It's good to hear from you. All right, cool. So today we're going to be looking at regression. We talked about this the other day a little bit. And today we're going to be just working through the general gist of getting you going on a single factor regression or a single explanatory variable. So for instance, what do you mean, Groom? Well, listen, we're going to measure dudes' waist sizes. All right. And then we're going to guess their weights. But what country, Groom? US of A. Would it be different in China? Well, of course. Why? Well, there's smaller people generally over there, so they're going to probably not have as big a waists. Besides, the American public is a bunch of fat asses, so you know what I'm saying. So clearly, right? Yeah, obviously. So clearly. So what if it was women's waist sizes? Well, let's see. Even a quote unquote chubbier gal doesn't have a big waist size. So the numbers obviously would not correlate to the same weights. So yes, do we have to be very specific in who we're discussing? Obviously, okay? Men, women, children in Turkmenistan, yeah, whatever. Yes, we have to be specific. So I'm going to say this. There's some guys, some normal size, little skinny guys. All right, there's some normal-ish dudes. There's a couple of normal fatties. All right. A little plump. They're pleasantly plump. All right. What do you weigh? Oh, 195, Groom. I weigh 195 too. That's exciting. I weigh 220. That's because you're short and pudgy, sir. That's true. I weigh 220 as well. Well, you're tall and scrawny. Quote unquote scrawny. Okay. 210, 235, 240, 230, 260, 260, 290, brah. Okay? So always, first things first, we always make ourselves a scatter plot. Not by hand, obviously. We're going to use Excel every time. Every time. And so, will you give me, Groom, the data already in? And well, no, probably not. Maybe sometimes, but sometimes I'll have to actually type it in yourself. But I'll try to help you out because I'm a nice guy like that. Shh, don't tell anybody. It'll be our little secret. I'm in a weird mood. It's been a while since I get to talk about math. Don't worry, I didn't really miss it. I mean, it was fun, but spring break was great. I don't know about yours, but it was pretty good time. 195, 195, 220. Is it weird that different people, size-wise, weigh the same? No, people are weird, bruh. All right. You know that one skinny person? Yes. Yeah, but they're ripped. Okay, sure, okay. And then what about that fat guy? Yeah, but he's got bird legs. Well, that's fair. Yeah, whatever, okay? So it is what it is. Yeah, I don't know. That one guy's got a giant melon. His head probably weighs 290 pounds by itself. All right, here's the game. So here we are once again. Ta-da, ta-da, ta-da. So we highlight. We insert. We're going to scatter plot. By the way, this looks redonkulous down here. You with me? Redonkulous. So what a guy can do, actually, if he wants to, if you click on the axes here, more options, and then on the axes, we went from 0 to 45. We could have gone from 30 to 45, if you will. That spreads that out, makes it look a little nicer. You know what I'm saying? I don't need it to do the math, but to me it looks nicer because then I can see, oh yeah, that's pretty linear for sure. Add a trend line. It's going to be a linear trend and and display. There you go. Done. Killer dog. So there it is. It looks like for every inch of waist size, I gain about 9.4 pounds. Are you with me, bruh? Okay. But Groom, what if I had a 0-inch waist? Then you'd weigh negative 112 pounds. Wait, what? Correct. That's weird. I know. No, I know, for real, right? Think about this. If you watch the population of Chicago from 1900 to 1970 or something, you see it going up like a bat out of heck. And you fit a linear regression of that. And then you follow back to the year 0. when Christ was born. And guess what you'd find? There was negative 10 gazillion people in Chicago. Well, that's not true. That's just the number that you need to have to make this thing work out right. Please don't freak out about it. Nobody has anything less than a 32-inch waist. So there's no such thing as a grown person with a 0-inch waist. Are you with me? Okay. If you found a grown man with a 12-inch waist, no, you didn't. No, you didn't. And by the way, if you did, if for some reason you've got some oddball 60-year-old man who never grew, he's still the size of a 2-year-old, that's an outlier, sir, and we're not interested in those people. Does that make sense? Because we're talking about the average American adult male, okay? I know this 30 guy on here is a reject weirdo because there aren't many 30 size waists in the U.S. right now, okay? We should have had some 54s in there too, but whatever. But irregardless, okay, 0, 18, 22, 28 doesn't even make sense, honestly. Okay, let's be honest now, okay? My oldest son is 6'6". If he wears a 36 to 34-inch waist now, he looks ridiculously scrawny, okay? Because he's so blame tall, okay? And so just be aware of that. Even ridiculously scrawny people, even a little tiny guy probably wears a 30-inch waist, 32-inch waist. So, in America, all right? So you're not going to see a lot of those. You're certainly not going to see a 0-inch waist, okay? So pay no attention to that part of it. Now, I do want you to note that we're supposed to be doing this in Google Sheets. So I'm going to pause for a moment. I'm getting into Google Sheets so you can see it in there. Okay, I apologize. Forgot to do this to you. So if you go under Data, I'm sorry, not Data. Damn it. Where's that? Extensions. You should see Excel Minor Analysis Tool Pack. If you don't, you're going to go to Add-ons. You're going to go to Get Add-ons. You're going to search for Excel Minor Analysis Tool Pack. And then you're going to click on it and hit install. Okay, see how it says install? Mine's already installed, but you're going to install that. Okay, once that's done, it's now loaded. That's exciting. So let me get my data back over here. My bad. So I forgot I was 90. Sorry. Leah's pissed at me. Groom's such a jerk, Mom. I don't understand him. Oh, damn it. Just a minute. Back, dumbass. All right, try this again. So let's paste. You dirty piece of dog crap. Can I just paste it, please? Now I'm angry. Hi, kids. Okay, so here we go again. Let's try it again. Is it copied? It looks like it's copied. Paste. Oh, hey, it worked. Weird. So here's what you're going to do. Okay. You're going to go to Insert. You're going to go to Chart. And when you click on Chart, it should, theoretically, and it didn't, you're going to look for this scatter plot, which is right here. Ta-da! And that, my friends, is how you get here. I'm going to unzoom myself because for some reason I'm zoomed in about 1,000% and it's kind of annoying. Somewhere. Hey, there you go, weirdo. Okay, so here we are. Back to this. Yay! Now, if you right click on that guy, you can go to oh, for God's sakes. Oh, just a minute. Pause. Pause. Okay, so if you click on right in here anywhere, if you right click anywhere and go to chart style, this thing pops up. Okay, if you go to series, you're going to go to trend line. Okay, so put it on there for us. We're going to hit show squared. And then you're going to click on this label. You're going to use equation. Okay, so there's the equation. And but I don't see my R. Oh, then R squared right there. Nice. So it's the same guy. It's got to go to a different spot to find it. Now, Groom, is that good? Remember, under the H naught for this guy, recall that our H naught is, there is no correlation. H naught, there is no correlation. That is, there is no relationship between your waist size and your weight. Versus, of course, there is a significant relationship. Okay? How do I know if it's good enough, Groom? Okay? I don't know. So let's go find out, shall we? Mm-hmm. So what a guy wants to do, move this stupid graph out of your way. Get out of the way, stupid. So you're going to want to go under extensions, and then you're going to go down to XL minor and hit start. Okay, so once you're in here, the side panel opens, and you're going to go for regression, linear regression. So first thing you want is to highlight your Y's. And then you want to highlight your X's. And it's very annoying about Google. You must highlight, then click in here. If you click in there, then highlight it, yeah, it's a whole thing. You'll be mad, I'll be mad, everybody be mad. That's how it goes. Da-da. Now, we will look at a little bit about residuals in the coming days, but for today, we're not going to worry about it. We're just going to hit OK. Oh, didn't give me an output range. You jackwagon. Down here somewhere, click an output range. And then it's going to spit out the stuff. And if you look, there's your p-value. 0.00000005. What does that tell me? It tells me this is a significant correlation between your waist size, right, and your weight, okay, for an American male. And so here is my equation. We say y hat, that's our predicted value, is equal to 9.39 times the waist size plus, minus 112.65. Okay, that would be it. So then if a guy were to ask you, hey, Mr. Grimm, can you predict how much a guy with a 37-inch waist would weigh? Yes, I can. Why, thank you. 37 times that guy, yes, plus this negative 112. That guy should weigh 234. Does that seem reasonable? Well, 37's right in here. That looks like about 234 right in that neighborhood. Yeah, I'd buy that for a nickel. Sure. Right on the line. Okay. That is what we are talking about. Okay. And so, huzzah, off to the races we go. Now, what I want you to focus on today is simply the process of, hey, there we go. We have our thing. Now, tomorrow in class, I'm going to do a couple more examples here, but tomorrow in class, we're going to talk a little bit about some of the what's behind the scenes that's going on here. What are we assuming that's true behind the scenes? Today, we're going to focus on getting you started, getting you answering some questions, getting you moving down the line, working on some of this stuff. Tomorrow, we're going to talk a little bit about some of our thought processes behind it. Wednesday, we'll talk part-time, work part-time, filling in some more gapioses and so on, and just keep adding on to what we have. Okay, that's the game. That's our game plan. Yay! Do another one, Grim. Oh, all right. Talk me into it. All right. So this is the length of your cat, and this is the weight of your cat. Now, Groom, I don't think there's any relationship there because my cat's short and fat. Well, maybe you're right. One moment, please, while I come up with some data. Okay, I got some data. Let's graph it. So, insert graph. It defaults to column chart, I guess. We're going to go to scatter plot. And then if you come down here under customize, horizontal axes, that's a lie, it's not horizontal axes, it's series, you dumbass. Series, trend line, show R square, and use equation. If you look at your R square, it's 0.23. You're like, is that very good? No, not great. Okay. Do I know if it's good enough? I don't. That's why I'm going to use XL minor. Okay. So again, here we go. So the nice thing about this is click this thing out of the way. So go highlight your data. Oh, is it the same data as last? Oh, it is, bro. Oh, that's hot. So notice I don't have to change my X's. They're already set up for me. Nice. Nice. I hit enter. Done. Done. And look at your F statistics. 0.13. This is not significant. Groom, what are you saying? Well, listen, pal. I'm saying you're failing to reject H naught. There is no significant correlation. Stop. That's all I want you to say. But shouldn't I predict? Groom, they want me to predict for a cat that's 18 inches long. Bro, you can do that, but that's a crapshoot, my man. What do you mean? Well, you can plug it into your heart's content. 18 times 2 is 36, minus 3 is 30, should weigh about 33 pounds. Okay? Theoretically, but there's no real relationship here. So do not predict. Don't even tell me. You just say there's no correlation, move on with your life. Okay? But Grim, I feel like move on with your life. But should I give you the no? Shut up, move on with your life. Because this is greater than 0.05, there is no significant correlation. Now, two more things I want to point out. A couple of these I've mentioned before, but I'm going to mention them again now. Again. So if you recall, I told you the other day, rho, this is the Greek letter rho. That's how you say it. This is the population correlation. Correlation is just the relationship between two variables. Okay? Who knows it? God knows it. So what do I want? Well, I'd like an idea. So I take R, which is the sample correlation, right? And based on the sample correlation, I can then, obviously, I'm not doing the test. The computer's doing the test. It's giving me a p-value, and we are rejecting or failing to reject H naught. If this is basically 0, then what do? Hey, we cannot make any prediction because it's not linear. It's not a function. If it's not 0, hey, what does that mean? That means there is a correlation there. That means that I can then y equals mx plus b, and I can go do a prediction. That's what it means. Now, R squared has a name. Is it the sample correlation squared? Well, that's what it is. That's not what we call it. It's called the coefficient of determination. What does that mean, Groom? It means this. It is the percentage of the change in y that is attributable to a change in x. What are you saying? Well, I'm saying as my waist size gets bigger, yeah, I imagine my weight's going to go up. True dat. True dat. But there's always going to be some variation. Okay? A shorter fella that gets an inch bigger gut on him, is he going to gain as much weight as a tall guy that gains an inch of weight around the middle? Probably not. Why? Well, because he's short, bruh. Oh, but he looks fatter. Yeah, he may look fatter, but I'm telling you that if you are 6'7" and put on an inch of belly fat, an inch around your waist size, that means your whole rest of your body has grown considerably too. And therefore, you're going to weigh a butt ton more than a person who's like 5'8" and puts on an inch of belly fat. Because yes, did he put on weight everywhere else? Oh, of course he did. But then the question is, there's not as much of him to go around. Does that make sense? And so it's not going to be as noticeable. That's all we're talking about here. Does that make sense? So just be aware of that. Okay. So the idea is this: there is some percentage that's attributable to change in x. You're like, well, what's the rest of it? The rest is because of what we call error, or if you will, randomness. Okay? There's just some randomness to it. In the case of a guy, like, it's random. I pick some people out of the crowd, and I happen to get a 6'7" guy, and a 6'4" guy, and a 5'8" guy, and a 5'9" guy, and whatever else, right? Those are random. Okay? And a 6'7" guy might weigh 400 pounds, but look just, meaty because he's just got some meat on his bones. All right? He's not really fat. He's just like, dude, this is a big boy. But he may just be 6'7". He may be scrawny too. Quote unquote scrawny. Like, but he weighs 230. Yeah, but he's 6'7", dude. He's bony, but whatever, right? So we're all built differently. There's always going to be that randomness to it. Okay? And so the idea is if most of the change is from X, then we will see we rejected H naught, meaning there's a correlation. A significant correlation. Does that make sense? Okay, and if there's not, then there isn't. So in our case here on this one, if you look at it, what was our R squared? Our R squared was 23%. Bro, that's nothing. Are you with me? That's nothing. And so what does that tell me? It tells me that I'm not shocked that I get a p-value of 0.13. That's pathetic. Okay. On the previous page, look what our R squared was. Our R squared was 85%. Whoa. Yes. Well, what does that tell me? Well, it says 85% of the change I saw in my weight, it was attributable to waist sizes. Only 15% was attributable to randomness. Okay. Which is, again, it's because I rejected H naught, because there's a significant correlation. That's why there's such a big R squared. I would like to point out R squared is 85%. That means R is about, what, 90-something percent? If you look right here, it's 0.92. Are you with me on that? 0.92? Could it just easily have been negative 0.92? Well, it sure could have been, right? Because that would have been going down, but then negative 0.92 times negative 0.2. Always positive R squared, obviously. Over here, if you look at it, again, we said the R squared was 23%. That means the other 77% of the change in the weight of your cat is for some other reason than how long the dumb cat is. Does that make sense? That's the game. All right, I'm going to make up some more data set here, and then we will be back with you. So I just went out and did a survey while you're waiting for me, and I counted how many orchids I saw in a particular flower shop, in a particular big box store like Home Depot or someplace like that. And then I went around and counted how many people I saw using chapstick. You're like, Groom, that seems weird. It does seem weird. Off the top of my head, Groom, I don't think... Holy crap, Groom! There's a relationship there. Correct. I do have one question for you. Does that seem like it's causing it, or does that seem like there's just some relationship I don't understand? Okay. So, for instance, okay, causal means, hey, the more calories you consume, the more you're going to weigh. Okay. Let's say the calories above 2,000 calories a day. Yeah, you're going to put on weight. That, duh. Okay. But wait. You know, the number of times you bang your head based on how tall you are. Yes, the taller I get, the more times I bang my head. Duh, how about that? There's things that are, one thing is causing the other to happen. Okay? How many times you cough? How sore your throat is? Yeah, huh? Okay, yeah. How about that? Okay. But here's a question for you. Okay, how much pollen's on the trees? How many Benadryl Groom takes in a day's time? I'm on 4 so far today, by the way. It's only about 3 o'clock. Yesterday was a good 6. And no, it does not put me to sleep. Don't worry about it. Now, this one here seems not causal. There seems like there's no relationship. We would say this isn't causal, it's casual. You're going to want to jot that down. Now, causal, casual. Okay, they both have a high correlation. So correlation can be causal, or, that's an A, or casual. Causal, dang it. Causal meaning that X causes change in Y. X, this is what causal means. Casual just means X and Y are related, though we may not know how. Because in the causal, X changes as Y. X causes a change in Y. But in this case, like, I don't get it, Groom. What's the relationship? Bro, I don't know, and I can't tell you. I just know that there is definitely a relationship here. It could be as simple as, hey, as the pollen count goes up, people have to have allergies, have to take more pills. Yeah, duh. Okay. That would be a causal relationship. Okay, but is it the pollen causing me to need pills? Yes. Okay. But what if it was the number of ice cream cones being sold and the number of pills Groom takes? Well, yes, because as it gets warmer, my allergies get worse. It's true. To a point, anyway. Okay? But ice cream cones versus bikinis. We talked about that one before, right? Because why? One's not causing the other one, but they're related. In that case, it's obvious. It's hot. So people want to people want to wear swimsuits, and people want to be, having ice cream. Okay, that one makes sense. This one makes no sense, and I have no problem telling you it makes no sense. It's freaking weird. So what I'm going to do is I'm going to customize, series, trend line, label it with the equation, show R squared. Holy buckets! 95% of the change that I see in X or Y is because of a change in X. Far out, bruh. Now, in our regression, kids, oh, you dirty hippie. In our regression, you're going to want to, escape. You're going to want to highlight that and then click in the Y's. It's very annoying. Then highlight the X's and then click in the X's. Most of you will screw that up 5 or 6 times. I know I always do. E23 is a random empty spot. That totally works for me, but if you want to put it somewhere else, you're totally welcome to. Look at this. Look at the p-value. There is 0 chance that this happened if there is no correlation. For God's sakes, look at your R, friend. Your R is it's negative 0.97. How do I know that? Because I got a negative slope. That's something to pay attention to. Excel would give it to us. Oh, darn it. Excel would give that to us as negative 0.97. You with me? But for whatever reason, the giggles isn't doing it. Dadgum you dirty hippie. Filthy hooker. All right, now, leave me alone. Now, as I was saying, that's negative. Because why? Because there's a negative slope here. Make sense? So you're like, Groom, let's ask how many orchids? Well, I want to predict for 5 orchids. All right, well, if I'm going to do that for 5, it would be simply a matter of equals, come on, darling, equals 5 times negative 9 point whatever plus 131. It should be about 82, 83 people using chapstick currently. Okay. What does that got to do with the price of tea in China? Nothing. Okay. It's simply a matter of doing the work on it, as it were. Nice. Now, that's the game. It's pretty straightforward, pretty easy to do. Can you predict for 30 orchids? No. Well, yes and no. Can I? Yes. Yes, I can. Should I? No. The answer is no, I should not. And why should I not? Because it's nowhere near my actual data set. Look what happens when Groom puts in 30. Look what happens. Boom. Plus. Boom. Not that. Boom. I get negative 160 people using chapstick. That obviously makes no sense. Your data set was built from 0 to 10. 30 is miles away. Remember, we call that extrapolation. And that's a dirty 4-letter F word, if you will. Okay. But Mr. Groom, it starts with E and it's 16 letters. I know, DA. Thank you. It's a dirty word. We don't use extrapolation. Okay. I will say this. Many years ago in the state of Washington, in the 80s it was, the early 80s, I think. This guy killed a woman pretty brutally, and he went to prison. In the state of Washington, it used to be if you didn't pick, you got hung, but you could choose lethal injection instead. Okay? And, okay, cool, whatever. So, and you may not know this, I'm just going to let you know. So, it turns out that the way that they took care of that was in the U.S. Army manual teaches how to do that, interestingly enough. But the manual only goes up to a certain weight. But the guy, after he was in prison, it just ate nothing but Twinkies. He got up to 400 and something pounds. And so he said, hey, listen, the manual only goes so far, so you have to extrapolate, and that wouldn't work, you see. And he got off on that technicality. They never did kill him. Pretty sad. So anyway, but Turns out that's not extrapolation. It turns out that's physics. Okay, you with me? There is a if this, then that sort of thing in physics. It always works. That's not a problem. That's different than this situation right here. This thing here was we came up with some data points. It worked. Yay. We fit a linear equation to it. Okay. So just some things we'll talk more about in the next couple of days. Extrapolation's one of them. Another thing we'll talk more about is causal versus causal. During 2020 and that fiasco, brother, everybody's running around, oh my God, correlation does not equal causation. Doesn't have to be causal. Frequently, though, it is causal. Okay. It's rare. And I mean rare. Hey, this guy's got Lyme disease. Has he ever been bitten by a tick? No. You know what that's called? Rare. Do you know why we know that ticks cause Lyme disease? Because everybody that gets bit by a certain kind of bug, that's where they get it from. Duh. Wait, what smoking causes cancer? No, it's totally casual, I feel like. No, that's causal. You know what I mean? And so on and so on and so on down the line. Okay? And so somewhere somebody got this thing in their mind, and it's true. It's true. Correlation does not equal causation. Doesn't mean it's causation. But oftentimes it does. And so in the last 5 or 6 years, we've had this pounded down our throats as if I'm kind of saying I'm a moron and don't understand that there could be a relationship that I don't understand. But in reality, a lot of times, no, that's we can see with our eyes, pal. Okay, there's a relationship here, and it's pretty causal. When these people do this, then they got that. Okay, and so it was one of those situations that happened during 2020. It was, if I had a nickel for every time I heard that stupid statement, I could have just, oh my gosh, I could have retired 5 years ago just about. Ridiculous. Okay, so we'll talk more about that in the coming days. So tonight, what you're going to be working on is some assignment. I'm going to pause you for one moment. Okay, so what you'll notice is we jumped up to chapter 12. For whatever reason in this book, she decided to stick, and I have no idea why. She decided to put regression as chapter 12 instead of 10, like every other book on the planet. But whatever. I don't care. Still going to do it this way because I feel like it. So it's on page 389 we're going to be jumping in at, and they're going to be doing problems like this. Please note that a lot of the ones that she does, this is all the X's or the homework 3s, and this is all the Y's. And so it's one long column when you put them in. Does that make sense? Okay. So the hypothesis, rho equals 0, rho does not equal 0. Nice. Correlation coefficient. Okay, we're going to use the computer to do that. Again, that's over here. Oh, shh. Dad, blame it. Just a moment. I close my giggle sheets. Just a moment, please. One moment, please. When it says compute the R and the R squared and all that, there's your R right there, baby. 0.92. You with me, dog? The computer is going to be doing it for you. No, you're not doing it by hand. That's just ridiculous. Compute the p-value. Again, there it is. State the correct decision. There is or is not a correlation. Yeah, reject H naught. There is a significant correlation or whatever, right? Compute the R squared. There it is. Okay, so in other words, 62% or 95% of the change in midterm grade is because of a change in homework 3 grade, if that would be the case here. Does doing poorly on homework 3 mean a student's going to cause the person to do bad on midterm? That's one of those ones where maybe, maybe not, right? If you didn't do good on the assignment, maybe you can do bad on the midterm too. It could be causal. I would suggest it's probably causal. But it could be used because you're lazy, Dom, and you didn't do the homework. Not you, obviously. I meant being it could be that you're lazy, didn't do the homework, see, and then that hurts your grade. I don't know what you're laughing about over there. I know what you didn't do your homework there, pal. Okay, not you, Dom. It's the other kid across the room from you. Yeah. All right. Anyway, so I'm just saying that. So yeah. And then find the standard error of the estimate. So that's one last thing I didn't mention here, and it's right there. The standard error of the estimate is this. We will be using that in the coming days. So there it is. Okay, so that's pretty much getting you comfortable with it. There's your p-value again, is right here. Okay. All right, that's what you're going to be working on. Homework will be posted. You can start working on the first few of those and get going. All right, bye.